Hi, my name is Aishi Jang, and today I'll be talking about the 4 emergent properties of water. This is the second video on the topic, and today we'll be talking about the ability of water to act as a solvent and the floating of ice. Now let's discuss the versatility of water as a solvent. First off, a solution is a homogeneous mixture of two or more substances. Now, a solvent is the dissolving agent of a solution, and the solute is the substance that's being dissolved. Now, when you have a solution where water is acting as a solvent, this is called an aqueous solution. When medieval alchemists tried to find a universal solvent, they discovered that water works better than anything. Well, water isn't exactly a universal solvent. It doesn't dissolve everything, but it's very good at dissolving a lot of things. The versatility of water can be traced back to the polarity of the water molecule. For example, let's consider dissolving sodium chloride in water. Now, the water molecules will form spheres around the chloride and sodium ions, keeping them fairly happy in the solution. This is called a hydration shell. As you can see, the hydrogen ends of the water molecule, which are partially positive charged, surrounds the chloride ion, which is negatively charged, and that keeps the chloride ion very happy. And the partially negatively charged oxygen atoms surround the positively charged sodium atom. In this case, we're talking about sodium chloride, which is an ionic compound. However, a compound doesn't need to be ionic in order for it to dissolve in water. Water is also very good at dissolving non-ionic polar molecules, such as sugars, for example. Now, any substance that has an affinity for water is said to be hydrophilic. However, not all hydrophilic substances will dissolve. Consider cotton, which is made up of giant molecules of cellulose. And cellulose has a lot of regions with partial positive charge and partial negative charges that can hydrogen bond with water. However, if you throw your cotton shirt in the washing machine, it's not going to dissolve. However, it does a very good job of soaking up this water because it's very hydrophilic. Substances that repel water are called hydrophobic. They don't like water. They are substances that are non-ionic and non-polar. An example of this is vegetable oil, which, as you know, does not mix stably with water-based substances such as vinegar. Now let's talk about ice floating. This has to do with the fact that ice is actually less dense than water. You can see here, ice is actually 10% less dense than water at 4 degrees. And water at 4 degrees is at its maximum density. At above 4 degrees Celsius, water acts as most other substances, expanding as the temperature increases. However, below 4 degrees, the slowing of the water molecules makes it harder to break hydrogen bonds, and thus the water becomes trapped in this crystalline structure, which one water molecule is bonded to 4 other water molecules. Again, it's because of hydrogen bonding that ice is less dense than water. Now, why is it important that ice floats? Well, let's think about it. If ice were more dense than water, then lakes would freeze from the bottom up because the ice would sink and then it would just keep building. Eventually, there would be no marine life. However, this does not happen in real life. Instead, what happens is ice freezes at the top of the lake, and since it's less dense than water, it's able to float on the surface. the ice actually insulates the water below, and therefore the water below is able to remain in the liquid state, allowing for marine life.